Hi guys. Yeah, I know it's a bit late, but today we're just going to be working on some vector problems from my last video. So yeah, let's get going. So number one, so we have to find a vector A with representation given by directed line segment. Line segment is AB. Okay, so our A is the ordered pair -1, 2, and our B is the point 2, 5. Okay, now we have to find a vector representation, right? Well, so we're given 2 points. None of them is the origin. So I think we have to kind of draw a Cartesian plane to represent these points. So how would that look like? It would probably look something like this. This is my y, this is my x. And it's probably, here's my A, which represents -1 and 2. And my B is probably somewhere here. Now you can just connect these 2 points, right? So I'm gonna use a blue one here. So that's that. So my B is here. Okay, and so we want to find, so this is vector A, because this is the tail and this is the head, or the tail and the tip, or the initial point and the terminal point. And now we want to find its, pretty sure we call it a position vector. So its position vector is gonna have to be, so starts from the origin, then it has to go at some point, but it has to face the same direction, but we don't know how long it is. And for that, we want to find the slope, right? So A and B are 2 points, and we can get their slope using the rise over run technique. So we want to get the slope. So given my A and B, you want to use that -1, 2, and 2 and 5. So it's going to be my change in y over my change in x. So it's going to be 5 minus 2 And then 2 minus -1 is going to give me 3, 3. Oh, would you look at that? It's y equals x. Slope is 1. So that means, all right, 5 minus 2 is 3. 2 minus -1 is, yeah, it's 1. Now we want to find the distance of those 2 points. So how far apart are they from each other, right? So that we can find the distance of our position vector. So the distance of the 2 points, we can use that distance formula in 2D. So it's going to be 5 minus, no, -1 minus 2. Then we square that thing. And then 2 minus 5. Then we also square that thing. Then we get 9 plus 9. So we get 18, square root 18. So that's the distance, right? So that means, let's check how, because I need a number for that. Yeah, so it's around 4.2-ish. So my distance from here should be the same, but this point has to be square root 18, square root 18, right? Oh, wait, no. Well, yeah, because my slope is 1. Or, or I could get the line equation of this too. And just go from there. It could do that. Huh. Okay, I'm gonna check how they do it. Because I have no idea. Okay. Oh, so we want to get the vector. Okay, my bad. Yeah, so I wanna get the vector. So that's the idea. So my bad. So I want to get the vector of AB. That's what I want to get. So I want to find that, right? So it's not necessarily the slope. It's just about getting the vector. So find this AB vector, right? And we're given these 2 points. And so, yeah, I'm pretty sure we just subtract it. Yeah, and then we should get something here. Yeah. Because AB is just going to be that vector some change in x and some change in y. Now change in y is just 5 minus 2. Change in x is just 2 minus negative 1. Or the other way around. It could be negative 1 and minus 2, and then 2 minus 5. And then we get something like negative 3, negative 3. And we just know that's 1. That's 1, 1, right? So this means my slope just goes from, or I mean, honestly, it could be, let me check. So it's like, I'm just gonna double check just to be sure. Yeah, I think it's just that. So this vector is just 1, 1. Yeah. So this is just gonna go to, I think the size is just 1. It's just gonna go somewhere straight here. And the point's gonna be like what? Um, could be negative 3, negative 3, could be, or honestly, I think, um, wait a minute. Okay. First thing we want to do is track the points. So we have negative 1, 2. Oh, wow. 2, 5. So it goes up. And then I subtract it here. And if I subtract it, but here I do it the example does the other way, which is weird, but I mean, yeah, I mean, this should work. Yeah, so it's going to be like negative 1 minus 2. Or it could even be like 2 minus negative 1. You can get like, um, honestly, I think any works. Yeah. I think I'm just, yeah, I think any works. Yeah. Okay, I'm going to go with this. Yeah, it should, I'll just type it in. It should work. Um, yeah, because I just subtract the coordinates. Or I don't need to simplify, actually. Hmm. Yeah, because it's supposed to be upright. And it needs to have the exact displacement. Yeah, okay. Yeah, so 1, 1, and negative, negative 3 are similar. But we want to make it in the direction that it's going. So from the origin, I think the best one's gonna have to be when it goes positive, right? I think it's the best way. So how this is gonna work is I'm gonna do the bigger number first, and then the smaller number. Yeah, I can't do it the other way around. Yeah, okay, I got it. So it's gonna be 2 minus negative 1, and then 5 minus 2. So it's going to be 3. So those are the components of this vector. And then for my position vector, it's going to be at 3, 3. So probably somewhere here. Hopefully. Yeah. Yeah. And then this is my 3, 3. Yeah. It has the same thing as this one. Okay. I'll just hopefully this works. Uh, we'll see. Yep. Okay. And now I move on to the next one. And a bit similar. And here, so we want to find a vector A. Sorry, I muted my mic. A vector A with representation. Uh, given by direct line segment, by directed line segment, AB. So same thing here. So we have for A 3, 0, negative 1. And then for B, we have 3, 2, 3. Okay, now I want to do the same thing, basically. So we don't even need to draw it. You just need to find a vector AB, like the previous one. It's going to be some change in X, some change in Y, and some change in Z, right? And we want to subtract B first to A in this case. So it's going to be 3 minus 3 for my X, 2 minus 0 for my Y, 3 minus negative 1 for my Z. And I should get 0 to 4. So yeah, this should work. So it's going to be 0 to 4. Yeah, so this has a Z in it now. Okay, and then now we draw this vector and the equivalent expression A starting at the origin. Oh, wow. Oh, wait, no, I'm wrong. This is not AB. This is vector A. I just realized. So this is A. This here is AB. Wait, am I tripping? Wait, no, they're both representations. No, I was right. Okay, so the next thing we want to do is we want to draw AB and the equivalent expression A. So I'm assuming A here is the position vector because it starts at origin. So here's what it says. Draw AB and the equivalent expression. Not expression. Representation. A starting at origin. Sorry guys, I know I'm making a lot of mistakes, but we'll get through it. Okay, so the vector AB, um, yeah, I mean, where does it start? That's what it's asking. Obviously, it starts at the point A and it ends at point B. So it starts here and it ends here. Yeah, because that's what I was asking. Where does it start? So I'm just gonna plug that in. Now, the vector A starts at 0, 0, 0 and ends at, 0, 2, 4, obviously. Yeah, we already did it before. They're just representations of each other. But vector A is basically the position vector because it starts at the origin. But their changes are all the same. Their change in X, Y, and Z is the same. Okay. Um, but yeah, they should be the same. Okay, I'm just checking. Yeah, no, I'm because I'm checking my homework and sometimes I'm not confident, but hey, we're getting it. We're getting it. Okay. Next, for the third one, we find the sum of the given vectors. So this is vector addition. So for this one, we're given vector A with 5, -3. Doesn't look like an arrow. And our vector B has components -4 and 9. And we want to find the sum of these two. And so A plus B. So we just add them. So 5 minus 4, -3 plus 9. So that's 1, 6. So that's that. Let me just quickly type it in. And now here it says to illustrate it geometrically. Well, okay. So we want to illustrate it geometrically. So I'm going to make a Cartesian plane here. Probably just an XY. Let's make it a bit down here. Okay. And we want to try doing A and B. So this is 5 and -3, right? So probably around here, 5 and -3. Yeah. And note that this comes from origin, right? So it goes to the right by 5, because this is change in x, right? This is change in x, change in y. And it goes down 3 times. So I'm going to say that's my vector A, right? My vector B, on the other hand, is it goes -4. So it goes 4 to the left, assuming y is the vertical axis and x is the horizontal. It goes 4 to the left and it goes 9 down. So I'm going to probably assume it's here. This is not drawn to scale. So this is our B vector. So what happens when we add? We're given, well, we actually have it here already. We go 1 to the right. Remember, our change in x and our change in y. So those are vectors. They have a change in x, they have a change in y, and if it's in 3D, then they have a change in z. So we go here 1 and up by 6. So probably here, maybe? Too much. Maybe here. So somewhere like that. Yeah. This is a plus b. This is my vector a plus b. Yes, it's like when b is pulling here, like b is pulling here, a is pulling here, then it's like ab is pulling here, which makes sense, right? I'm kidding, it doesn't. Doesn't make sense, but it's okay. Um, yeah, I think that should be it. Wait, no. Wait, no, 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 no. A plus B. Yeah, because I added these two. 9 minus 3 is 6. Yeah, see, I'm still getting confused with vectors, but delta. Yeah, see how this kind of doesn't make sense. Uh, let's check the behavior, yeah. It goes -3 downwards, 5 to the left, 5 to the right, -3 down, negative, and then for B it's -4 to the left, and then 9 going down. So that makes sense. But then when you look at A plus B here, it goes 1 to the right, and then 6 up. But when I'm looking here at because it's a multiple answer thingy, I can't seem to find it. So it means I must have missed something. Um, no, I'm thinking. Huh. Because all the B's here go up, which is weird. Yeah, it's only my B that's different actually. A and B. Wait, let me see. You have an A here. You have an A plus B here. Ideally, my B should be up here. Should be somewhere there. Hmm. Yeah, because then that would make sense. Because this one, also, if you look at my vector A, yeah, I think, no, my vector A is right, definitely. My B is not right, though. It's negative 4, 9? Oh, so it's negative 4 to the left, but should be 9 up. So, so it's negative 4 and then 9 up. So that's my B. Yeah, and then my AB is somewhere like this. Yeah. Yeah, now this makes sense. Oh, there's so okay, that's funny. Because I still don't see an answer that's similar. Or I'm just deranged. Or I have no idea. Um, wait. Yeah, I added it. It's 1, 6. I'm gonna check it on Desmos. Yeah, so it goes 5 to the right and 3 down. That makes sense. Vector B starts at the tip of vector A. And then it goes uh the tail and the tip? Really? Oh, that's weird. Oh, yeah, now that I realized it, I actually don't know where A is going. Is it going the other way or yeah. Um yeah, I just realized that. I don't know where it's going. Yeah, so it should start at the tip of vector A. It should go for and then vector B should go 4 left and 9 up. And then A plus B goes from origin directly to the tip of vector B. Yeah, I did A correctly. A plus B correctly. Okay, let me see. Because yeah, I mean, Vector A. Oh, I see what I did wrong. Yeah, this should be here. So this should be B. Yeah. Mm-hmm. Yeah. We'll see. It, but yeah, I think it should be that though. Yep. Okay. Um, Probably do like what, two more? Then I'll call it a day. Anyway, so we find the sum of the given vectors. So that thing we did a while ago, we're probably gonna do the same thing. Okay, so my A is 501. My B 080. Right? And we just have to get the sum of these two. So it's gonna be A plus B, 5 plus 0, 0 plus 8, 1 plus 0. Oh, all that 581. Right? So I'm just gonna type that in. Now, so here, illustrate geometrically. So A starts at 000, and it ends at 501. Right? Oh, so it's that trick again. So I have to think in 3D. Now here I have to think, where do all these places go? Right? So what I think is B starts exactly at the tip of A, right? So without even the thing here, right? A starts at the 000, right? Uh, the origin, and ends. This one's a no-brainer. Ends at 501 because that's a given. And B should start at the tip of A. So B starts at 501. And now it should end when we add A plus B, right? Because we have to add 501 to the B thing, the components of B. So 581, right? And so A plus B starts at this origin. Yeah, and ends at the same spot where B ended. Also ends at 581. Now I cannot visualize this. It's really difficult to visualize this. But there's a graphing software in the exercises I'm doing, so. But the idea is there. Like it should. I mean, you can try, but Actually, let's try. Let's try. Let's try visualizing. So let's see. This should be something we can do. If not, then it's okay. I don't expect to do it. So this is my Z, my X, my Y. Okay, so my A starts at origin, right? It ends at 501. So I go like 5 times, 0Y, and then 1 up. It's probably here, right? So that's my A vector, or my A. Probably put an arrow. Okay. And then now B starts here, and it ends at 581. So I don't move my X at all. So I'm not moving back and forth. But my Y, I'm going to move 8 times. So I'm going to move here. My Z, I'm not going to move anywhere. So I'm not going to go up. Yeah. Starts here, goes here. Okay, so it's like a 3D thing. I can't even see it from this angle. And then my A plus B is there. So it goes goes there. Yeah, if we were to probably actually let's do that. This is my Y. This is my Z. Actually, I think I made it even worse. Maybe like an upper view would be good, right? But basically what this is you have a vector here. That's A. And then you go B here. Then you have C going here. Basically, that's what this is. It's just they have to go up to see it. But yeah, I think it should be that. Okay, let me just plug in the stuff. So 501, and it ends at 581. And then the A plus B starts at the origin. And it ends exactly at 581. Yeah. Okay. Let's I actually want to see this. And you just add it. Oh. But yeah. I think it should. Oh, I'm zooming in the graph. Okay. Let's submit and see. Not sure though, but yeah, got it. I should be more confident with the answers I'm getting. Anyway, okay, this is going to be our last one. I'm gonna continue this tomorrow, or I might move on to a new topic. Probably go through dot products because that's the next one. But yeah, so this is my last one for now. After this, I'm gonna call it a day. Okay, so here we find a plus b. I'm assuming these are vectors. 2a plus 3b. The magnitude or the length of vector A and the length of A minus B. And we're actually given the vectors here. So you have 12, -5. For B, we have 4 and 1. Okay, now we start with A plus B. So A plus B is just adding these. So 12 plus 4, -5 plus 1. Then you get 16 minus 4. Then we have 2A plus 3B. So this is 2 times A. So 2 times this vector. Then I add it to 3 times the components of B. And so I get something like 24, because I'm multiplying it here. -10 plus 12, 3. And then I can add these. So I get 36. -10 plus 3 is -7. Should be, right? I think I'm brain dead. Yeah, -7. So that's that. And now here's where it becomes different, because now I'm looking at a certain length of the vector. So now I want to find the length of this vector here. So I have to use the distance formula, right? And it's the length of this vector from 0, 0, which is obviously just 12 minus 0 squared, -5 minus 0 squared. So just square these two. And I get 144 plus 25, and I get 169. So square root of 169, which I think has something. Yeah, has 13 here. So that's the length of that vector. And lastly, the length of, I keep saying length, or the magnitude of vector A minus B. And we already found, no, I'm kidding. We have to find A minus B first, right? So it's the length of vector A, and I subtract it to B. And then I get 12 minus 4, 8, -5 minus 1, -6. And now I have to find the length of that vector. So I use the distance formula again. So I get 8 squared plus -6 squared. And I get 64 plus 36. And I get some value out of that. I square it. So square root 100. So that's 10. Oops. Yeah. I'm going to plug in these answers and we'll see. So I have 16 -4. So here I'm referring to a vector. 2a plus 3b is 36 and -7. If you guys know, honestly, I want to know some applications using vectors. But lately I've been doing this applications to physics, I think, which was part of our course. It was pretty fun though, because I got to see like how you can literally like use a vector on anything, and I mean anything, like the wind, the plane, the boat, Yeah, I'll show it. I'll show it after I plug this in. But basically, like vectors can be applied in real life. And I did Google up a bit, and you need to know vectors in machine learning. So maybe you guys can help me learn more about that. Or you guys can recommend me books or courses or something. But yeah, that's also part of the reason why I'm going through this course. It's because I want to know more about the math behind data science and machine learning because I am a bit curious about the field. So yeah, let me see if we got this. Not confident, but we'll see. Yeah, okay, maybe you should be more confident. Okay, I'm actually gonna show you guys real quick what I mean. So basically, we did this thing where was it? Is it here? Yeah, it was here. Okay. So this girl launches a boat from south shore of a straight river. Okay, basically, there's this boat and the wind is like forcing the boat to go that way, right? And she's rowing this way, right? And so if there's like two forces that are acting like that, then there's this resultant force, which is where she's actually going. Because if you're being pulled from here on one side and you're being pulled from the other side, then you're gonna go that way, right? Because that's just how physics work, I guess. This is probably just how physics work. So yeah, we denoted this as VC, which is the velocity of the river. It's like going west, and the velocity of the boat. And then we did some trig facts just to get the change in x and y. But basically the idea is we want to get that resultant velocity. But the task for this problem is to find out this angle. What's the angle that she's going to steer? And in order to do that, we need to find the vectors. We need this vector. What is that? Well, that's the vector -4, 0. Because the change in x is -4, it's going to the left. But the y-axis, there's no change in y in this vector. And then this vector is in the problem, it's this 8 miles per hour. So this is probably 8, 1, which is exactly what I did here. But then you need to take into account the cosines and the sines because you need the angle. So you get that, the 8 cosine theta and 8 sine theta. So it's not just 8 and 1. And then to get the resultant velocity, well, you have to add both of these vectors. So you want to add this vector here, and you want to add this vector here to basically get this one here, which is where she's actually going. And yeah, we just denoted it as ijk because we can do that. And the course of the boat is directly north, and we were able to get the angle, which was 60 degrees. So that's how much angle she should steer, sorry, to arrive at the desired landing point because she wants to arrive exactly the opposite shore. Because right now she's in the south shore, so she wanna go she wants to go to the north shore, which is the exact opposite of south. So yeah. Yeah. And yeah, this one also has a nice application to it. It's the weight that's going down. But basically, like the idea of these problems is you want to put vectors in everywhere. There's a vector here, there's a vector here, there's a vector here. And you want to get those vectors, you want to add them up. And then, yeah, pretty much fun stuff. But yeah, these are some fun stuff. But I think what's really confusing for me is where the direction is. Like in the like here, I can't really tell which direction it's going, but I realize, yeah, it should be going at the same way because this is the position vector. So yeah, I hope you guys enjoyed. I'm really tired, but I'm gonna keep doing this. Because it's also really good for learning, when you talk and you like it's different when you say what you're thinking. You actually learn more by doing that. So I'm trying to do that. But I mean, if you guys learn something, then I'm happy. But yeah, that's it for today. I'll call it a day, or should I say a night? Yeah, I'll see you guys in the next one. Oops.